2.2 lecture for precalc, discussing higher ordered functions or higher degree functions. So instead of working with the x squared, now we're moving on to x cubed, x to the fourth, x to the fifth. So you can look at an interactive example in your online textbook, but we want to know some shapes of these graphs before we get started. So when you look at them, you know what's going on. Remember that the leading coefficient is the number that's in front of the variable that contains the highest exponent. And greater than 0 means positive, and less than 0 means negative. So think about these things up to this point, see what you know about them, and then pause the video now, think about it, and then come back and look at it. So remember, when it's positive, you're going to have one of these two graphs. This one we refer to as an S shape. It's got the S shape, and then obviously this one is the U-shaped graph. So we describe the S as it goes upward from left to right. So down to the left, up to the right, that's when it's positive. If it's negative, if the leading coefficient's negative, up to the left, down to the right, or an upside down U. And there could be some hills and valleys within the graph, but we can't tell that just from the leading coefficient. If the degree, remember, is even, so a power of 2, a power of 4, then they're the same direction. So what they talk about is a U-shaped graph, opening up or opening down. Or if the degree is odd, we have the S-shaped curve. And again, then you look above and you determine what's the leading coefficient doing. So I could do some examples where I have positive and different degrees. So maybe something that is in the x to the fourth with some other terms. I could go in and say, okay, well, x to the fourth, if it's positive, the tails have to go up. So it might do something like this. It might come down and kind of create the W graph. But notice both tails in this particular graph point upward. I could also do an x to the fifth type graph. Maybe there's a positive 3 in front of it or something. But it's going to start down here and end up here. So I could go up and then crisscross over this. So it could be a crazy graph, but it goes down to the left, up to the right. Whereas this one, when it's negative, now with an x, even an x to the sixth, let's do negative 2x to the sixth. Could be other terms again. But this one would be maybe something like this. Both tails pointing down. And then maybe a negative 7x cubed. Could just look like a negative x cubed, a S-shaped curve negative. Doesn't have to have necessarily hills and valleys, but up to the left, down to the right. So take note. All we know from degree and leading coefficient is the basic shape, S or a U-shaped graph, and which way the tails are going. We do not know anything about the intercepts, maxima or minima at this point. So when you do look for zeros or relative extrema, the polynomial functions, you're looking through here, where does it cross the x-axis? Those are zeros. Output is 0, that kind of thing. A graph can have repeated zeros or multiplicity of 2. So somebody might write down something like x equals 1, 5, and negative 2. Well, they all have multiplicity of 1. There's just one of each of them. Whereas if somebody else writes down x equals 2, 2, 7, and negative 7, the ones that have multiplicity of 1 are 7 and negative 7. There's only one of each. But 2 has multiplicity of 2. There are 2 of them. So what we're going to do is go to a graphing calculator and we're going to type in this function. So on my calculator now I have this equation typed in, and we're going to go ahead and look at the graph. And it's this S-shaped curve, and I can kind of see right here that the graph passes through, whereas over here it bounces. So I can tell when I go to write this that it has multiplicity of 1 at 0, and then this is 1, 2, 3, 4, 5. So my answer most likely is x equals 0, 5, and 5. You write down where it touches the x-axis. Bounces have even number of zeros, so you could have 4 of them, 6 of them, and multiplicity of 1 means it passes through. So the next part of this is to go ahead and find all the zeros of this one. So no calculator. So what I could do is each one has an x. And then this would factor the quadratic. We could go x and x minus 6 minus 6. So I have answers that are 0. This is just 0. And then when you set x minus 6 equal to 0 and you add 6 to both sides, I get a 6 and a 6. So this tells me there's a bounce. So if I put the 0 at 0, and I go 1, 2, 3, 4, 5, 6. Now remember, x cubed right here is S-shaped, positive. So it's going to start down here and end up here. So I go through, I pass through this one because it's multiplicity of 1, bounce off that one because it's multiplicity of 2, and there's your graph. Just remember zeros, solutions, some people say roots, kind of all mean the same thing. They are x values that make the output 0, or they are x values where the graph touches the x-axis. If I tell you that what a factor is, you should be able to solve it, set it equal to 0 and solve it, find the zeros. And x-intercepts are basically what I just said. It's where the graph touches the x-axis. All right, so working it backwards, if you know what the zero is, what factor did it come from? You simply write x minus the number. So x minus 3 is my factor. Then you write x minus negative 4. Most people will simplify that to x plus 4. And then here you would say x minus 0. And again, most people would simplify that down to just x. So those are pretty straightforward. Just write x minus the 0. When you have a polynomial that has a solution that's 2/3, and you write x minus 2/3, basically we can just bring this denominator in front of the x, and we'd rather see it written as 3x minus 2. It'll yield the same result, but it also is going to have an effect on the leading coefficient. So when we design exams, we do the same thing as teachers. We just go x minus negative 2, x minus 2, and x minus 5/2. So we pick some numbers that we think we want you to find. So this would be x plus 2. And I'd write this one as 2x minus 5. So we're going to go ahead and multiply. I would do these two first, FOIL them. So I get x times x is x squared. Now remember, the the middle is 2x, and the outside is negative 2x. So they go away, that's 0. And 2 times negative 2 is negative 4. So there's no middle term there. And now we're going to multiply x squared times 2x is 2x cubed. X squared times negative 5 is negative 5x squared. And negative 8x, that's 4 times negative 2. And negative 4 times negative 5 is positive 20. Now, to make sure that this is correct, I'm going to go to the graphing calculator and type that function in and look at the graph and make sure that it's hitting it, negative 2, 2, and 5 halves, or 2.5. Okay, so I've typed in my answer, 2x cubed minus 5x squared minus 8x plus 20. And when I look at the graph, I want to make sure it's hitting at negative 2, good. It hits at 2 and what looks like 2.5. So I'm relatively sure that my answer is correct. If you make a small error on that particular graph, you're not going to be able to see these answers. So now you're going to do the next one, the DIY. So go ahead, plug it in, do your multiplication, check it on the graphing calculator, and then I will show you the answer. So pause the video now and come back and look at the answer. So here is what I did. Instead of writing x plus 1/2, I did 2x plus 1. 0 just means it's an x, and x minus 3. I multiplied these two first, and I got this. And then at the end, multiply by your x, and this should be your final answer. So on this problem, probably the easiest is just to factor out an x cubed, and it leaves behind negative x plus 3. So this one gives me 0 3 times, and if you set this one equal to 0, x plus 3 equal to 0, I would just move the x to the other side, and I get x is 3. So now if I put those on the graph, I have zeros here, and 1, 2, 3 here. And at the very beginning, I see that it's x to the 4th, negative. So I know it's U-shaped, and both tails have to point down. So I'm going to draw it like this. And I'm not sure if there's some other stuff going on, and I don't know where that maximum is located, but that's what it would be. So on the next one, the DIY, try to pull out the x, try to factor that quadratic. Go ahead and graph it, and then check your answer. So pause the video now. So here you can see some of the factoring. I pull the x out, have this quadratic, I factor it, I find my zeros. They all have multiplicity of 1. So when you put them on the graph passes through. The original graph is positive x squared. And then the table of values is plugging in some x's between. We're plugging in x's between the zeros, and you're finding some output. So you can have a little bit more accurate graph by doing that. But it's not necessary to do that, but it's just more accurate.